We are discussing today electromagnetic induction EMI and alternating current circuits. From these two topics, in fact, 1 to 2 questions are expected in the final examination of EAMCET, and usually they are formula oriented. So, if you are recollecting the formula once again, that would be better. So, EMI, electromagnetic induction, when we talk about, what are the major equations we have to remember? The very first one is, what do you mean by magnetic flux? That's what we people used to write it as phi. And of course, the general formula is B dot A, we write it. So, the moment it is a dot product, you should understand that this is a scalar quantity, not having any direction. But according to B dot A, we can even write this one as BA cos theta. Theta is what? That is angle. Angle made by the normal drawn to the plane with the direction of the field. I repeat, theta is angle made by the normal drawn to the plane with the direction of the magnetic field. So, if at all you consider the value of theta as 0, then of course we can understand the value of phi is going to be maximum. That in the sense we can write this one as BA. By any chance, if theta becomes 90, then automatically we can write the value of phi becoming minimum and its value will be 0. So, according to Faraday's laws of electromagnetic induction, we can now understand the induced EMF in this particular case, that is E, if I write, that is d phi by dt, the rate of change of magnetic flux linked with the coil. This of course we people used to write it the other way also. It is phi is equal to BA. Therefore, n turns if they are there, nBA by T we can write with a negative sign. We used to show that. That negative sign has been given by Lenz. So, it is what is called as Lenz law. It is an application of law of conservation of energy as such. So, that is one more point here you have to remember. Suppose in this equation, if B is a variable, then how to write this formula? NA into B2 minus B1 by T. Suppose A is a variable, NB into A2 minus A1 by T. Like that we people used to write the value of EMF. That is actually the concept. So, come to the next one please. Suppose there is a magnetic field this way. Why we people are taking up into, so you can understand the direction is into the board. Suppose there is a rod like this of length L, which of course is AB here, which is moving across this one with a velocity say V. Then you can certainly understand what is going to be the motional EMF across this particular rod. Motional EMF is equal to BLV. That B is going to be the magnetic induction of this particular field applied. L is the length and V is the velocity with which it is going. Suppose if it is making an angle theta with the length like this, and if this is the direction of velocity, then we write the same formula this way, BLV sin theta. That is actually the concept. So, whenever theta is given, this is the formula. When theta is not given, this is the formula we have to remember. Come to one more application here. Sometimes that fellow may say there is a rod which of course is hanging this way. This is the point O, which is the fixed point through which or from which that is hanging. Now, there is a magnetic field applied. Once again, the magnetic field is applied perpendicular to the board and the direction is towards the board, that means into the board. Now, what that fellow says is, if this rod of length L is rotating like this inside the magnetic field, this is actually the magnetic field what has been mentioned, then what is going to be the motional EMF here? The induced EMF in this particular case is half BL square omega. Omega is called angular frequency. So, these are few formulae we have to remember. Come to the next one please. N phi, which is actually called the flux linked with a coil having N turns, is directly proportional to I. I is the current passing through that. In other words, you can write the same N phi is equal to Li. L is called coefficient of self-induction. This is the point what you have to remember. So, coefficient of self-induction, when they ask you to calculate n phi by I, is one formula for us. Likewise, one more equation we have. The induced EMF is equal to, that is, L is equal to E by di by dt. Like that also you can write E by di by dt. That in other words, you can say induced EMF is equal to L times the rate of change of current. And of course, E we write it as Henry. That Henry otherwise is called volt second per ampere, or you can even call that one as ohm second also. So, this is one formula you have to remember. If there are two coils by any chance facing each other or very closely placed to one another, then the same constant L what we have written here is called as mutual induction coefficient. So, that time we write once again n phi is equal to Mi. What is this M now? Coefficient of mutual induction. This is another formula you have to remember. So, the second one is M. What is M? It is n phi by I. This is one formula for us. What is the other formula for this one? M is equal to E by di by dt. Like in the case of L, what we have already discussed. Now, even M also will be in Henry, or you can even write the same thing as ampere, that is volt second per ampere. In other words, you can write ohm second. That is actually the way of remembering the units. Come to the next one. Taking this mutual induction into account, they have given us the concept of a transformer. Transformer, of course, we will be having two coils inside. One, of course, is a primary coil, we call it. One is called secondary coil, we call it. This is primary, this is secondary. But observe carefully, if secondary number of turns is more than that of primary turns, then that is called step-up transformer. If secondary number of turns is less than the number of turns in primary, that's called step-down transformer. What actually a transformer used to do? It used to convert high current low voltage into low current at high voltage, or vice versa. And another thing, it works only on AC. That means what? It cannot function for direct current. It just works for alternating current only. Remember this point. What is the basic equation we have to remember here? Sometimes they used to give you transformation ratio. What is this transformation ratio? Nothing other than secondary number of turns by primary number of turns. That is what is called transformation ratio. So, you can have a formula here. N secondary by N primary is equal to EMF across secondary by EMF across primary is equal to current across primary by current across secondary. This is the concept you have to take up. And of course, whenever we talk about a transformer, we always used to consider that one as ideal transformer. What is this ideal transformer? It is a power output and power input when they are equal. That is what we call it as ideal transformer. In other words, E secondary into current secondary is equal to E primary into current primary. This is the formula you people have to remember. So, these aspects one has to remember as far as electromagnetic induction that is concerned. Now, come to the next one. What about AC? While talking about AC, very few formula you have to remember. What is average value of current? What is RMS value of current? In fact, we know this one 2I0 by pi. And of course, what is IRMS? It is nothing other than the value of I0 by root 2. So, two different values you have to remember here. Coming to the next one over here. What next we have to take up? When only resistance circuit we consider, then you will be finding current and EMF both are in the same phase. Remember that point carefully. When only inductor if you take up, inductor circuit of AC, then you will be finding current lags behind EMF, right? By what value? By pi by 2 radian. You have to remember this. Coming to the next one, only capacitor circuit when we consider current leads the EMF, by how much again? By pi by 2 radian. This is another point. Now suppose if you take LR circuit, what is the formula that is to be remembered? For effective resistance, that is what is called impedance, is equal to root of R square plus XL square. What is XL now called? Inductive reactance. XL is equal to omega L, that is the formula. If you take for example for CR circuit, then impedance Z is equal to root of R square plus XC square. What is XC called? Capacitive reactance, that is 1 by omega C or C omega, that is the formula. If you consider all the three put together in series, that is what we call it as LCR series circuit. LCR series circuit. Suppose if you consider such circuit here, then what is the value of impedance? Z is equal to root of R square plus XL minus XC whole square. In other words, R square plus omega L minus 1 by omega C whole square. This is actually the formula. But suppose if I say XL is greater than XC, that circuit becomes inductive by nature. And suppose if you say XC is greater than XL, then that is called capacitive by nature. By any chance XL and XC are equal, then we can say that is in resonance, and that time it is resistive circuit. That means only resistance will take the lead. So this is the point. And XL is equal to XC means what? Omega L must be equal to 1 by omega C. Therefore, resonating frequency will be 1 by 2 pi root LC. This is the formula you have to remember for resonating frequency. So these areas one should remember before taking up the applications of this particular chapter, AC circuits and even electromagnetic induction concepts of it. So let us take few applications based on all these formulae whatever we have taken up just now. A primary coil and a secondary coil are placed close to each other. A current which changes at the rate of 25 ampere in a millisecond is present in the primary coil. If the mutual inductance is 92 into 10 power minus 6 Henry, then the value of induced EMF in the secondary coil is how much? Look at carefully what are the values given. di by dt he gave. How much? 25 ampere per millisecond. Milli means 10 power minus 3. So you can write this one ampere per second. And what else he has mentioned over here, the second value? It is 92 into 10 to the power minus 6 he gave in terms of Henry. That is the self-induction coefficient he gave. What is E the question? L di by dt. That is the direct formula. So what we should write now from this? 92 into 10 to the power minus 6 into di by dt, that is 25 by 10 power minus 3. Cut this one 10 power minus 3 times. Now of course 2 into 25 it is going to be 50, it is 5. 9 into 25 means it is 225 plus 5, 230. Right, into 10 power minus 3. So it should now be 2.3 volt. That should now be the value. So what is the value that is tallying over there? You look at second option is being tallied with that 2.3 volt. That is the corresponding option for this first problem. Look at the second problem now. The time constant of inductance coil is 3 millisecond. When a 90 ohm resistance is joined in series, then the time constant becomes 0.5 millisecond. The inductance and the resistance of the coil are respectively how much? That is the concept. time constant, you should remember two things here. First one is inductive time constant. Inductive time constant. This inductive time constant we call it as L by R. And second one is capacitive time constant. Capacitive time constant, of course, we write it as CR. So these two formulae you have to remember generally. Now in this particular question, he is talking about inductive time constant. L by R is given 3 millisecond, 3 into 10 power minus 3 second. Then what did he say? 90 ohm resistance is connected in series to this. Then total resistance now becomes R plus 90. That time, what is the time constant given? It is 0.5 millisecond, 10 power minus 3 second you can write. Now you just take the ratio please. R plus 90 by R is equal to this by this. 10 power minus 3 gets cancelled and 3 by 0.5 it is 6. So 6R minus R is equal to 90. That means 5R is equal to 90. Then R will be 90 by 5. Of course, you will be getting 18 ohm over here. So resistance value is 18 ohm. That means certainly first option is correct option. But what is L also we want? So simply from this one, L is equal to R into this value. 18 into 3, 54 into 10 power minus 3 Henry. That only you can write 54 millihenry here. So 54 millihenry is L value. 18 ohm is R value. These two are the answers what he is asking for. That is the point 2. Second one, the first option is going to be correct for the second problem. Look at the next problem, that is problem number 3. A metal rod of length 2 meter is rotating with an angular velocity of 100 radian per second in a plane perpendicular to a uniform magnetic field of 0.3 Tesla. The potential difference between the ends of the rod is how much? Just now I have reminded you while taking up all the formulae of this chapter. Whenever a rod is rotating, the motional EMF in that particular case is half BL square omega. Direct formula, if you remember, that's easy for you to get the answer. Half you write it as it is. What is the magnetic induction that has been mentioned? It is 0.3 Tesla. Length is given 2 meters, so that length square becomes 4 into omega, that is angular frequency, that's given 100 radian per second. You cut this one twice, this point and this 0 you cut it off, you will now be getting exactly 60 volt. 60 volt, see that option carefully. Third option is going to be 60 volt for this question number 3. So for third problem, third option is the correct option there. Look at the next problem, that is problem number 4. 8 microfarad capacitor is charged by 400 volt supply through 0.1 mega ohm resistance. The time taken by the capacitor to develop a potential difference of 300 volt is how much? One of the values, of course, he has mentioned in brackets, given log 4 to the base 10 is 0.602. That is a concept. Now, where from actually we have been taken this particular question? We are having growth and decay of charge in CR circuit. You people can all understand growth and decay. In what? In CR circuit. CR circuit, when you take, what is the formula for growth? Charge Q is equal to Q naught into 1 minus e power minus t by CR. That is the formula for growth. And for decay, generally we used to take the same. Q is equal to Q naught into e power minus t by CR. This is for decay. So these two are the formulae you people have to remember. One for growth of the charge in CR circuit, one for decay of the charge in CR circuit. Now in this particular question, this is the formula what we people have to take up. Now Q in terms of voltage you write V is equal to V naught into 1 minus e power minus t by CR. That is actually the formula we can take. V is given 300. V naught is given 400 into 1 minus e power minus t by CR. What is C given? You see, C is given 8 micro, that is 10 power minus 6, into what is the value of R given? 0.1 mega. Mega means 10 power plus 6. So these two they get cancelled. Are you not getting 0.8? The value of CR here, please? Write down the same value here as 0.8. I think this step is clear to all of you. Look at the next one. If you cut these two zeros, 3 by 4 is equal to 1 minus 1 by e power t by 0.8 I write. This is t power minus we are having, that is 1 by I write. This in other words I can rewrite the same this way. 1 by e power t by 0.8 is equal to 1 minus 3 by 4, which is 1 by 4. Come on, denominators you equate them. E power t by 0.8 is equal to 4. Now take logarithm. Log 4 to the base e is equal to t by 0.8. What is log 4 to the base e? 2.303 into log 4 to the base 10. What is that value given? 0.602. He gave that value 602 into 0.8 is equal to the value of t. So this t value he is asking you to calculate. If we simplify the total lot, t comes to be around 1.1 second for us. So this is the calculation and one of the best model questions we have based on these two formulae, please. This is growth of charge in CR circuit. This is a decay of charge across a CR circuit. That is the point here to be noted. So for fourth problem, the correct option is going to be the second one. Look at the next number, that is problem number 5. A coil of 1200 turns and mean area of 500 centimeter square is held perpendicular to a uniform magnetic field of induction 4 into 10 power minus 4 Tesla. The resistance of the coil is 20 ohm. When the coil is rotated through 180 degrees in the magnetic field in 0.1 second, the average electric current induced is how much? That is the concept. First of all, identify the data what has been provided to us, then automatically you will get the corresponding formula. A coil of 1200 turns, that is capital N, that is given there. And of course, area he has given you 500 centimeter square. You better write 10 power minus 4 meter square. Okay, then what is magnetic induction given? 4 into 10 power minus 4 Tesla, that is the value of B. And what did he say? There is a resistance of 20 ohm and in what time it is reversed there? In 0.1 second time, it has been rotated by 180 degrees. That means it is reversed totally in its direction. Now what is his question? What is current? The question. In fact, we know induced EMF is equal to N B A by T. When it is reversed, double it will be. So 2 times NBA by T. That is one aspect. But E can be written as IR. Current into resistance is equal to EMF. Now I want the value of I from it. So you can write 2 NBA by R into T. Every value is mentioned there. So you can write 2 into 1200, 2400 into B, that value is given 4 into 10 power minus 4 into the value of A, that is once again 500 into 10 power minus 4 whole divided by the value of resistance given, that is 20 ohm, into what is the time that has been mentioned, 10 power minus 1. Simplify that one now. 1, 2, 3, 4 zeros and 10 power minus 4 I can cancel. This 20, of course this goes, totally 5 goes 4 times. 4 and 4 they get cancelled. This now goes up, it becomes now 10 power minus 3. So 24 into 10 power minus 3 ampere, that is the value. But all of you can understand 10 power minus 3 is also called milli. Therefore, 24 milliampere, that is the corresponding answer for us. So, second option is going to be the correct option for this question number 5, please. Look at the next number, that is problem number 6. A long horizontal rigidly supported wire carries a current IA is equal to 96 ampere. You can directly understand what is mentioned over there. Look at, first of all, there is a horizontal wire like this. It is now carrying a current IA, 96 he gave, that is the value in ampere, fine. Now what did he say? Directly above it and parallel to it, at a certain distance, another wire of 0.144 Newton weight per meter carrying a current of 24 ampere in a direction opposite to that of IA. There is one more wire like this, which is now carrying a current IB. How much he has given you that one? 24 ampere, that is given. And what is its weight given? Weight is given 0.144 Newton, that is the point. Now he is giving us a clause. What is that? If the upper wire is to float in air means what? It should not fall down. When will that be possible? If the repulsion between these two wires and weight are equal and opposite, then there is a possibility for it to float in air. So what is this question then? What is the distance of separation between these two? Now you can understand weight must be equal to force of repulsion between the wires. What is weight given? 0.144, okay. But what is force of repulsion formula? Mu naught by 2 pi I1 I2 L by D. But what has been given as weight here? You see, weight per unit length is given. That means this length he has brought this side. So this is per meter. That is now 2 into 10 power minus 7. That is mu naught by 4 pi into 96 into 24 whole divided by D. Now what is the value we want? D we want. It now can be taken 2 times 24, it is 48 into 96 into 10 power minus 7 whole divided by 144 into 10 power minus 3. This cancels minus 4 times. Now you directly can cancel the things and simplify the total lot. You will be getting exactly 3.2 into 10 power minus 3 meter you get. But in fact the options are given in millimeter. Therefore if I multiply it by 1000, I will be getting 3.2 millimeter as such. So 3.2 millimeter is corresponding to the third option for this particular problem number 6. One of the best models what we people are having here. Right. Look at the next one, that is problem number 7. Two parallel rails of a railway track insulated from each other and with the ground are connected to a millivoltmeter. The distance between the rails is 1 meter. A train is traveling with a velocity of 72 km per hour along the track. The reading of the millivoltmeter is how much? He has given us vertical component of Earth's magnetic induction is 2 into 10 power minus 5 Tesla. Definitely you can once again understand it is a motional EMF across the track. What is the formula for motional EMF? I have already mentioned BLV. L is the separation between the rails. V is the velocity of the train whatever is passing. And B is now to be called vertical component of Earth's magnetic field. So what is vertical component that has been mentioned? 2 into 10 power minus 5. L is nothing other than the distance of separation between the rails. It is 1 meter given. Into 72 km per hour he gave. That is nothing other than 20 meter per second. So it now becomes 40 into 10 power minus 5. In other words, 4 into 10 power minus 4 volt we can write. So what are the values he has given you? You see there. This now can be rewritten 0.4 into 10 power minus 3 volt. 10 power minus 3 again is called milli. Therefore, 0.4 millivolt if I write, that tallies with the third option for this particular question number 7. So, this is what is called motional EMF in the case of a train which is passing on the rails which are separated by a distance of 1 meter and across which a millivoltmeter that has been connected over there. Look at the next problem, that is problem number 8. A wire of length L is bent into a coil of 1 turn of radius R1. Another wire of the same material and same area of cross section and same length is bent into a circular coil of 2 turns of radius R2. When same current flows through both the coils, the ratio of magnetic induction at the centers of the 2 coils will be how much? Now, the concept you people should understand, this is a part of electromagnetism concept in fact. We know magnetic induction at the center is mu naught by 2 into Ni by R. That is actual formula we know. Now, when there is only one turn, you can directly understand B1 is inversely proportional to R, you can directly write it. That R of course is R1 he is talking about, fine. Whether capital or small, hardly that matters for us, it is R1, okay. Let us write that way. Now, the question is the same wire of same length, same area of cross section, everything similar, but it has been molded into 2 turns. Simple logic you can all understand. When 2 turns we have, R automatically becomes R by 2. And the number of turns will now be 2. So, what will be this value now? 4 by R1 you will be getting. So, what is the ratio is the question he is asking you. So, what will now be B1 by B2? It will definitely be 1 by 4, that is 1:4, that should be the ratio. So, 1:4 means what you should understand? The third option is going to be correct for that. This in fact I have told you earlier also, when n number of turns when you make it, the value of B at the center becomes n square times. That is the point based on which it becomes 1:4. Look at the next problem, that is problem number 9. A magnetic flux of 500 microweber passing through a 200 turn coil reversed in 20 into 10 power minus 3 second. The average EMF induced in the coil will be how much? That is the concept. In fact, we know very well EMF is equal to phi by T or n phi by T. N number of turns and all of course we can understand. But it is reversed once again. Reversed means already I have briefed you. This value now becomes the maximum, 2 times it becomes. So, what we can write now? N is 200, okay. And what is the value of phi that is mentioned? 500 microweber. So, into 10 power minus 6 into 2 by what is the value of time in which it has been reversed? 20 into 10 power minus 3 seconds. So, first thing you can do is 1, 2, 3, 4 zeros you cut here minus 2 times. This 10 power minus 2 cuts over here minus 1 time. This 0 and this 10 power minus 1 they get cancelled. This 2 and this 2 they get cancelled. What is now left over? 2 5s are 10. What? Volt. So, 10 volt must now be the corresponding induced EMF across that particular coil. So, fourth option is going to be the correct option for this question number 9. Look at the next problem, that is problem number 10. A wheel having a metal spokes of 1 meter length between its axle and rim is rotating in a magnetic field of flux density 5 into 10 power minus 5 Tesla, normal to the plane of the wheel. An EMF of 22 by 7 millivolt is produced between the rim and the axle of the wheel. The rate of rotation of the wheel in RPS is how much? RPS of course everyone of you know revolutions per second or rotations per second. That is what is natural frequency is asking you. In fact, E is equal to half B L square omega. That is the formula. Now you can even rewrite the same this way, half BL square into Omega can be written 2 pi n. N being the frequency, 2 gets cancelled. Now n I want, n is equal to E by B L square pi. That is actually the formula. N being the frequency here. So what you can write now in this case? How much EMF that has been produced there? He has mentioned the value that it is producing. Magnetic field he has given you. EMF is 22 by 7. That is 22 by 7. What? Millivolt he gave. So into 10 power minus 3 by B. What is that value of B? 5 into 10 power minus 5 into what is the length given? Each spoke is of 1 meter. So 1 square will be 1 only again. This pi again is 22 by 7 only. You can understand that. You can cancel these two. This one cancels minus 2 times. So you will be getting 100 over here by 5. So totally 20 you will be getting. So how many rotations it is making per unit time now? That is 20 rotations that is making. So 20 RPS is the correct answer, which tallies with the second option for this problem 10. Look at the next problem please, that is problem number 11. If a change in current of 0.01 ampere in one coil produces a change in magnetic flux of 2 into 10 power minus 2 Weber in the other coil, then the mutual inductance of the two coils will be how much? That is the concept. Now what are the values he has given you? First of all, check that one. Change in current, that is I has given you 0.01 ampere, that is delta I we can call it also. And of course, what is the magnetic flux that is being varied over here? Delta phi that has been given 2 into 10 to the power minus 2 Weber, as such he has mentioned. Now you can all understand phi. N phi is proportional to or is equal to Mi. There is a formula like this. M is called coefficient of mutual induction. I have already told you. So M we want. N he has not mentioned, means it is understood it is only one coil having one turn. What is phi here? 2 into 10 power minus 2 divided by the value of I. It is once again 10 power minus 2, because this can be written 10 power minus 2 ampere. So cut these two. So what is now left over? 2 what? Henry. So 2 Henry must be your answer. That now corresponds to third option for this question number 11. Look at the next problem, that is problem number 12 please. If the flux of magnetic induction through a coil of resistance capital R having n turns changes from phi1 to phi2, then the magnitude of charge that passes through this coil is how much? That is the concept. Charge that passes through this coil. In fact, we people can understand charge if I write it as Q. It is n into delta phi by the value of R. Directly you can understand. What is n into delta phi here? Delta phi is nothing other than phi2 minus phi1. Or sometimes phi1 minus phi2, in this particular case phi1 to phi2. That means phi2, let us take it as more, because he is giving the all options in the same order. So phi2 minus phi1 by R the resistance. So this now must be the charge corresponding to that passes through this coil is n times phi2 minus phi1 by R. Charge is inversely proportional to resistance in this case and directly proportional to the change in magnetic flux. That is a point you have to remember. So second option is going to be the answer for this. In fact, it is more like a formula one should remember. Come to the next problem, that is problem number 13 please. A constant voltage of 25 volt is applied to a series LR circuit at t is equal to 0 by closing the switch. What is the potential difference across the resistor and the inductor at time t is equal to 0? That is the point you have to remember. Now LR circuit he is talking about. This is L, this one is R like this. This is actually the concept. And how much voltage he has mentioned here? 25 volt that has been applied across this. That's what it is R, this is L. One thing one should understand here, when time is 0 means what? We have not started applying this value to the system as such. Then what will be the potential difference across the resistor? Across the resistor VR automatically will be 0. Then what about this value? This will now be across this particular inductance coil. So VR will be 0 and VL will be 25 volt over here. So which option that is correct over here? You check that one. 0 and 25 volt, that now should be the very first option for us as far as 13th question that is concerned. Look at the next one, that is problem number 14. A series LCR circuit is connected to a source of alternating EMF 50 volt. And if the potential differences across the inductor and capacitor are 90 and 60 volt respectively, the potential difference across the resistor is how much? A wonderful model question. Several times in recent past, I am talking about in 5-6 years of EAMCET papers, if you see, same model at least you will find 2 times. That means a very commonly asked model question it is. LCR series circuit, that is L, this is C, this one is R. This of course is the one what he is talking. And how much EMF that has been applied across? 50 volt, he said like this. Fine. What are the values he has mentioned carefully? The potential differences across the inductor and capacitor are 60 and 90. It is 60 volt here and 90 volt here. Now, what is VR? That is the question. Voltage across the resistor he is asking. But according to the phasor diagram, we can directly take these concepts like this. Look at, this is the direction of VR if I take, this will be the direction of VL and this will be the direction of VC. Remember this order carefully, always along horizontal direction VR, upwards VL and downwards VC we take. Now you can understand VL is given 60 volt. VC is given 90 volt. Now which is more, you can understand this is more. So the resultant will be downward. How much it will now be? 30 volt. How do I get 30? 90 minus 60 will now be 30. In which direction it is? Downward direction. And what is VR that is to be calculated? What is the resultant voltage he has given you? That is given as 50 volt. You know very well between VR and the resultant of these two is not the angle 90 please. So V resultant square is equal to VR square plus VC minus VL whole square. That is the formula. So what will now be the value of VR square please? 50 square minus 30 square, which now will be 40 square. Then what will be VR? Automatically you will be getting that one as root 40 square, which will now be 40 volt. 40 volt means which option that is correct there? Third option is going to be correct for this question number 14. Right? Look at the next number, that is problem 15 please. A capacitor of capacity 0.1 microfarad connected in series to a resistor of 10 mega ohm is charged to certain potential and then made to discharge through the resistor. The time in which the potential will take to fall to half its original value is how much? Already we have discussed a similar model earlier, almost similar. Same concept now also. Q is equal to Q naught into 1 minus e power minus t by CR. That is actually the concept what we have taken up. Now you can understand in this case, this can be rewritten V is equal to V naught into 1 minus e power t by CR. What is this V given? Half of this value, that's what has been mentioned, is equal to V naught into 1 minus e power minus t by CR. Now you can cut this one over here. So what is now left over please? E power minus t by CR is 1 minus 1 by 2, which now will be 1 by 2. So in other words, you can write e power t by CR is equal to 2. Then logarithmics if you apply, log 2 to the base e is equal to t by CR. Now see what is the value of C given please? 0.1 microcoulomb. So I calculate CR separately. 0.1 into 10 power minus 6, that is microcoulomb, into what is this value of R? 10 mega. Mega means 10 power 6. These two they get cancelled and this gets cancelled. How much this value be? 1. So you can directly write this way. T will now be equal to log 2 to the base e. How much is its value? 2.303 into log 2 to the base 10. All of you know log 2 to the base 10 value directly also. That is 0.3010. That value is given there in that problem also. If you multiply this one, 0.693 seconds you will be getting. 0.693 seconds is the second option that has been given for this problem number 15 now. So second option is correct for this question. Look at the next one, that is problem number 16. The following is just giving us a small circuit here please. Look at that one. The following LCR series circuit when driven by an EMF source of angular frequency 70 kiloradian per second. Angular frequency is omega. 70 kiloradian per second. That is the value given of omega please. Now what are the values he has mentioned over there? You look at. He is just giving us a circuit here. This is the capacitor. There is a resistor like this. That is actually the one what has been mentioned. Here 100 microhenry, that's the value of L given. That is one value you have to remember. And this is 1 microfarad he has given you. That is the value of C. And coming to the third one, that will now be R, which is 10 ohm. So for this particular question, one should remember this circuit first of all. It has not been given there. So I am drawing that one here. Look at the circuit carefully. This is the circuit. Now the question, if you look at the options you see, purely it is resistive. Series RL circuit, series RC circuit, series LC circuit with R is equal to 0. These are the options. So first you calculate XL. What is that XL? Omega L. L is known, omega is known. 70 into 10 power minus 10 power 3, right, into the value of L, that is 100 into 10 power minus 6. Calculate it and keep it aside. XC you calculate 1 by omega C, that is 1 by 70 into 10 cube into what is C? 1 micro 10 power minus 6. If you calculate these two, you will find that XC will be greater than XL. When XC is greater than XL, it is capacitive circuit along with resistance. So it should now be RC series circuit. That means what? The third option is the correct option for this particular question. Okay. Look at the next problem, that is problem number 17 please. The inductance L in millihenry of the coil, which is to be connected in series with a capacitor of 0.3 picofarad to get an oscillatory frequency of 1 megahertz is how much? That is the concept. Oscillatory frequency, that means it is in resonance, it is understood. Resonance frequency is equal to 1 by 2 pi under root LC. That is actually the formula what we have. Now his question is, what is the value of L? Therefore square it up over here. N square into this 4 pi square N square is equal to 1 by LC. So what can we write? L is equal to 1 by 4 pi square N square into C. Every value of course we know 4 pi square into what is N here given? 1 megahertz. So 10 power 6 whole square, 10 power 12 into what is the capacitor value given? 0.3 picofarad, 10 power minus 12 farad. So simplify this whole lot please. You will be getting exactly 84.4 what? In terms of Henry, you will be getting that value over here. So it will now be millihenry, because 84.4 into 10 power minus 3 Henry you will get. So 80.4 millihenry will now be the correct option. That is the second option for us over here. Look at the next number, that is problem number 18. A step down transformer has primary voltage 1100 volt. Transformation ratio is 1:5. Just now I have mentioned the transformation ratio is nothing other than number of turns in secondary by number of turns in primary. That is now given 1/5. But according to the formula I have already told you, E secondary by E primary or I primary by I secondary. Come on, equate these two first. Then equate these two later. You will be getting both the options whatever he is asking for. So primary current is given 10. So 10 by secondary current. So what will be the secondary current here? 50 ampere. So secondary current must be 50 ampere. That is one answer. And what else he has given you? Primary voltage 1100. Come on, equate these two. 1/5 is equal to E secondary by 1100. Then what will be E secondary here? 1100 by 5. That of course 220 volt you will be getting. So 220 volt and 50 ampere. So first option, that is the correct option for this particular question number 18. Look at the next number, that is problem number 19 please. A condenser of 10 microfarad and an inductor of 1 Henry are connected in series with an AC source of frequency 50 Hz. The impedance of the combination will be how much? Impedance of what? Impedance of LC circuit. That's what he is talking about. So impedance means Z. It's nothing other than XL minus XC. So what is XL over here? L omega. L omega in what way you can write? L is given 1 Henry into 2 pi into N is 50. So you can write directly 100 pi what? Ohm. That is XL. What is XC now? 1 by omega C. That is 1 by, what is omega again? 100 pi into C. What is that C value given? 10 micro, that is 10 into 10 power minus 5. So XL you have got, XC you have got. Simply take the difference of these two. That now gives you the resultant value over here. If you take the difference, exactly these two are going to be equal. Equal means 1, 2, 3 zeros you cancel. 10 power minus 2. This goes up now. You directly can get this value 100 and this is 100 pi. Even here also you will be getting the same value. That is omega into C. That of course you can take, since these two values are equal, you will be getting the first option. That means what? The effective value here is going to be simply 0. That is the point you have to remember. Look at the next problem, that is problem number 20 please. An LCR circuit, series circuit contains L is 8 Henry, C 0.5 microfarad and R 100 ohm. Resonant frequency of the circuit is how much? That is the concept. Resonant frequency, observe that wording carefully please. N is equal to 1 by 2 pi root LC. So you can directly write 1 by 2 pi times root of, what is L given? It is 8 Henry, fine. What is C given? 0.5 microfarad. So 5 into 10 power minus 7 you can write. 8 5 is 40. So 1 by 2 pi root 40 into 10 power minus 7. You can cut this one minus 6 times. So 2 into 10 power minus 3 will come out. 1 by 2 pi into 2 into 10 power minus 3. Bring this 10 power minus 3 up. It becomes 1000 by 4 pi. 4 cancels 250 times. So 250 by pi hertz will now be the corresponding resonating frequency for this question number 20 please. Look at the last number, that in the sense is for 20th question, 250 by pi, third option is the correct option for us. Look at the last number in this order please, that is 21st. In an AC circuit, the potential difference across an inductance and a resistance joined in series are 16 volt and 20 volt respectively. The total potential difference across the circuit is how much? That is the concept. Fine. Now you can understand once again, this is the voltage across resistor, this is the voltage across inductor. I have already briefed you earlier. Voltage across resistor is how much he has given you. You see that one there. Inductance it is 16 volt, resistor it is 20 volt. What is the angle between them? 90. Therefore, resultant voltage will now be VR square plus VL square. VR square is 20 square 400, VL square 16 square 256, both under root total 656 under root. Common sense says, had it been 625, we would have got exactly 25 as the answer. It is above 625, so our answer should be more than 25, that too a little more. So what is the correct option here? 25.6 volt will now be the correct and the resultant voltage across that particular series circuit of LR. These are the points, of course, what we have to remember as far as this particular chapter that is concerned. But remember all of you, in electromagnetics topic, we are having three parts. Electromagnetism is one, electromagnetic induction the second one, and alternating currents is the third one. In all the three put together, 3 to 4 questions you can expect. Minimum of 4 questions you will be getting in EAMCET paper on 10th of May. Therefore, if you are thorough with these concepts, I am 100% confident that every one of you can definitely score 4 marks from this particular electromagnetics topic.